Yeah, hi friends. In this video, we are discussing about how to deploy Azure Kubernetes services using Terraform. So in the previous video, we have discussed already how to deploy AKS cluster using Terraform, and in that video, we have also deployed application gateway ingress controller. So in this video, we are not using application gateway ingress controller. So instead of that, in place of that, we are using Nginx ingress. Okay, so we are using Nginx ingress controller. We are also following the same module approach. So let's open the Terraform code. Okay, so we are using 4 modules in this Terraform AKS cluster deployment. First one is service principal. So you can see that main.tf file. This is the main.tf file. So we are creating the service principal here, and we are storing the service principal secret in Azure blob. Okay, so this is the code, and outputs, we are providing the outputs here. So if you want, you can use the Terraform root module. Okay, so this is the service principal, and the second one is vnet. You can see the document here. So what we are creating in the vnet means we are in the Azure subscription. So we are creating a vnet. So inside the resource group. Okay, so in the vnet we are creating 2 subnets only. So we are not creating app gateway subnet here because we are not deploying any app gateway. Okay, one subnet is for bootstrap node and another subnet is for AKS node pool subnet. Okay, this is the architecture diagram, so you can refer my blog. Okay, so let me open vnet. Here you can see that I am creating a virtual network and I am creating here 2 subnets. So I am using count variable. So with this count variable you can create a number of subnets with this lines of code. Okay, so output also I have provided here. So I need vnet id and subnet ids, so that's why I have provided outputs here. And next one is key vault. So we are creating key vault also. This is used to store any secrets, like any secrets and certificates. That's why we are storing here. So we will store Azure secret. So Azure service principal secrets we are storing here, and this is the output, key vault id. And next go to the AKS module. So this is our AKS module. Okay, so this is our AKS module. So we are getting the Kubernetes versions by using the data resource. So we are using managed identity. So we have 2 types of identities here: user assigned identity and managed identity. Managed identity is created with the resource. So once you destroy the resource, automatically the resource also the identity also gets deleted. So that's why we are using user assigned identity. This resource you have to manage yourself. Next, this is the AKS cluster block. Okay, so we are mentioning the AKS cluster name here and the location in the resource group name, DNS prefix. Private cluster enable false. If you want to enable private cluster, you can put it to true. Okay, so role based access control also true. Kubernetes version, you can pass the Kubernetes version here. Okay, so in the locals I have written like this: selected Kubernetes version equal to where.kubernetes version. If you want to provide, you can provide the version, which version you want. Here it will take that version. So if this is empty, it will take the latest version. Okay, so next I have taken this SKU tire equal to free. So these are the tires available: standard, premium, and free. And automatic upgrade channel equal to stable. YADC issuer enabled equal to true. So I have enabled YADC issuer. So in AWS it is in different way. In here it is just check mark the box. Okay, this is also same workload identity enable, also check mark in AKS cluster. So this is the default node pool we are creating. So name of the node pool is you can write it here. So VM size is this one. So some of the values I have hard coded, so if you want you can variabilize it. Okay, so I have enabled the auto scaling, and I am creating this cluster with one node. Minimum count is 1 and maximum is 3. Okay, and the disk size is 40 GB, and the maximum ports equal to 100, and type equal to virtual machine scale set. This is the subnet ID. In this subnet ID all the node pool will be created. You can set the node labels and the tags. So here you can mention the identity type, and this is user assigned type. In the previous video I have created the cluster using service principal. So one of the either you can use either service principal or the identity you can use. So this is related to network profile. So this is the username and password of the node pools. So here we are creating the public key and private key by using this resource, and we are also storing the private key in Azure storage or Azure storage account. Okay, so from there you can take that public key, and you can connect to the Azure node pools. Okay, so that's why we are storing this in Azure storage account. So this is for spot nodes. This is the resource name, Azure Kubernetes cluster node pool. Okay, so this is for spot nodes and regular nodes. You can change the priority to spot or regular. Okay, so this is for extra node pool. So this is for system resources like kube system namespace. All the system related pods will place into this node pool. All the application related pods will place into this node pool. So that's why we have created two node pools here. But in this demo I don't want to create this one. I will go with the this one. I will go with this one. Okay, so this is the about the AKS module. Okay, so let's come out from the module. Let's get how to implement this root module. Let's check. This is my provider.tf file. You can check. I have mentioned Azure RM and Azure AD and Kubernetes and Helm resource. Okay, and provider Azure. I have also mentioned provider Azure AD and provider Kubernetes, provider Helm. So when you install any resources like a Kubernetes related resource, so it won't install. We need provider for that. That's why we are providing provider, Kubernetes provider and Helm provider. Okay, backend state file also we are storing in the Azure container. Okay, for that we need to create one storage account and we need to create one container. Okay, this is my main.tf file. So I have mentioned one resource group, service principal module, and role assignment. So we are assigning the contributor level access to the subscription. and module, key vault module. This is the key vault secret. This is used to store the secret principal client secret. Okay, service principal client secret. So this resource is used to store the service principal client secret, and this resource is used to store the SSH private keys. So this is for VNet, and this is for AKS resource. So this is for your kube config file. It will save the kube config file in your local, so that you can directly access kubectl get config. So it will automatically connect to your cluster. Okay. So this is the VM. So this is the bootstrap node where I have showed you in that architecture diagram. This is the bootstrap node to connect to our AKS cluster. Okay. So for that we need public IP, network interface, and network security group. So I am allowing only these ports 100, oh no, sorry, 222 and 80 and 443. So we need to associate this Azure Network Interface Security Group Association, and this is the virtual machine resource. Okay, so you can check the configuration of my virtual machine. For that I have passed the computer name, username and password. So if you want, you can use the SSH keys here for security purpose. So this is the null resource. Okay, so I am using remote execution. We are installing these scripts. One second, let's go to the bootstrap.sh. So I am installing Azure CLI and kubectl and Helm install. These three I am installing in bootstrap node. Okay, and role assignments. You have to give the contributor role to the Azure resource group and network contributor role to the VNet level. So this is the ingress resource, Nginx ingress resource. We are installing this Nginx resource using Helm. Okay, so this is the name of the ingress controller, and the repository, the chart name of the chart, and the version namespace. You can write the namespace here. So if the namespace is created in your cluster, you no need to mention this one. If the namespace is not created, then you have to mention this rows. Mention this. Okay, so if there are any failures while deploying this through Terraform, you can reapply without any issue. It will not throw any error and the second time. So that's why we are providing this one, cleanup on file. It will clean all Kubernetes, all Nginx resources. Recreate pods equal to true, replace equal to true. So these are the values we are providing here. Controller.replica count, node selector, and default backend controller.service external traffic. So this is depends on module.aks. So this is the Argo CD also we are installing through Helm. So this is also the same, the ingress resource. Here also we need to provide values, Helm values. If you want to access Argo CD with 80 port, means insecure, you have to enable this. If you want to access this using HTTPS like 443, you don't need to provide this. You can simply ignore this block. Okay, so this depends on ingress, Nginx ingress. And finally this is the set manager. Set manager, this is used to, it will provide HTTPS certificates like. Okay, okay, so these are my variables. These are the variables I have used to create the AKS cluster and the remaining things. So let's try to deploy the cluster using Azure Pipelines. Okay, so let's go to the browser. Okay, and this is the pipeline. So this pipeline is for destroy the resources, and this pipeline is for to create the resources. Okay, so this is my pipeline. These are the stages, the stage validate stage. So I am installing the Terraform here, and I am init the Terraform init in this stage, in this step. Here we are validating the Terraform validate, and the next stage is deploy stage. So as this is a separate stage, again you need to do the Terraform init and Terraform apply. So the same thing we have mentioned in the destroy pipeline. So instead of apply, you can destroy it. So when you run the pipeline, it will destroy all the resources. When you run this pipeline, it will create all the resources. Okay, let's try to run the pipeline. So this is the one. So this is the pipeline. So we need to create all the resources. You just click on run pipeline. Okay. As you can see here, the pipeline is running. Compared to AWS, so Azure is very fast in creating the things. So it will take 9 to 10 minutes to create the cluster and all the resources. So here something is failed. I need to check it. Service principal key vault vnet modules retrieving. So there is no storage account created. So let's create it. So I will create the storage account. Where is it? Go to the one second, backend. Just go to the backend. Search for the storage account. Storage account. So create the storage account. So this is my storage account name. And select this Azure block storage. So I want to select this one. So click on next. So you have to enable this anonymous access. Just click on access. Click on next and create the resource. And next we need to create the container. So this is the container. This is the container name. So it will take a while to create the storage account. Okay, let's wait. Just go to the resource and create the container. So under the data storage, we have containers. Let's create a new container. This is the name of our container and give the anonymous access. Okay, so container has been created successfully. Okay, so this is our container. So let's run the pipeline again. Just go back. So you can click on rerun failed jobs. Or you can go back and click on run pipeline. Okay, so let's see. Okay, so Terraform validate is successfully completed. Now deploy. So now it is deploying the resources in the attempt to. Let's check. Okay, total 24 resources. It's creating. It's creating the resource group now. So you can see it's creating the resources. So once go to the virtual machine. Once the virtual machine is created, let's connect to the virtual machine. Okay, so it will take hardly 9 to 10 minutes to complete these resources. So let's open the super putty. Okay. So these are not the errors. You can see here. These are not the. This is not the errors. So as per the documentation I have written here. So why Terraform is showing this type of errors here? So this is expecting this type that equal to like this. Again, if you want to set another value, you have to mention like this. So this is the way it is expecting. But as per the documentation, in this way you can write. It will not throw any error when you run the pipeline or when you run the Terraform deploy. Okay. Let's go to the VM. So this is our login name and this is our password. Okay, so once the VM is created, so we can access the VM by using super putty. So let's go to the Azure Pipelines. So when you run the pipeline for the first time, so it will fail at that time. So you have to go to the Microsoft Entra ID. So Azure Pipelines is creating the resources by using service principal. So it is automatically created on service principal here. Just go to the Microsoft Entra ID and application registrations. Just go to this resource. And click on all applications. So this is our service principal, so which is created by the Azure Pipelines automatically. So once the service principal is created, just click on that and click on manage. Go to the API permissions. Okay, you have to click on add permissions. And here you can click on Microsoft Graph and again application permissions. So here just go to the application and check mark this application read write all. So once this is done, just click on this grant admin consent for default directory. It will pop up yes or no. You can click on yes. Okay, so this is the one step you have to do it manually. Let's check the resource group. What are the IAM roles we have applied on that resource group or not? So on the subscription level, what are the IAM roles we have applied? So this is the subscription I am using now. Okay, so just click on access control. So just click on role assignments. So this is the one. On the subscription level, you have to give contributor access to the service principal. So this is the one. And also you have to give Key Vault administrator access to that service principal to store that to store keys, and user access administration. So these three you have to give. So this is automatically assigned, and this is the one you have to create it manually, and this is the one you have to create it manually on the subscription level. Just go to the Azure Pipelines. So these are the things you have to do it manually. Okay, let's click on the pipeline. So it is almost completed. So after installing the set manager, this is the set manager we are installing through Helm, and this is the cluster issuer. So you can install issuer or cluster issuer. If you want the certificate for a particular namespace, you can use issuer. So if you want the cluster level certificate, you can use that certificate to any namespace, and that time you can use cluster issuer resource. Okay, so this resource we will create it manually. So let's go to the pipeline. So now it is creating Argo CD. I think the VM is also created. Let's connect to this VM. Copy this public ID and paste it here, and just press enter. It will ask password. You can copy the password from here. So if you want, you can use SSH keys to connect Azure VM. So let's switch to the root user and go to the /temp/bootstrap. Okay. Or it's tmp/bootstrap bootstrap.sh. Just press enter. Okay. So these three are installed automatically. These three are installed automatically when you create the virtual machine. So here I am executing these two lines to connect to the AKS cluster. Okay. We are successfully connected to the AKS cluster. Let's type kubectl. So get nodes. So we have created a cluster with one node. Okay. This is our node. This is our worker node. Let's get into the pipeline. Okay. So this is failed because of these two lines. These two lines are not executing through remote execution block. So that's why it's failing. The same error it is showing. So there is no problem with that. It is created all the resources. Only this pipeline is failed because of this error. So if you want, you can put these lines. If you don't want, you can simply remove these two lines. Okay. So if you want, you can put this one, these two lines, or you can simply remove it from here. Okay. So all the resources are created successfully. So I have connected to the bootstrap node. Let's check the Helm resources are created or not. Helm list -a. You can see here we have enabled the workload identity, so it is created. And Argo CD we have installed using Helm. It's also installed. You can see the status here: deployed, and set manager deployed, and Nginx ingress controller also deployed. Let's check the Nginx ingress pod. It is running or not. Let's check. Kubectl get pods in which namespace? In ingress basic namespace. Okay. See, you can see the two pods are running. Okay. Just go to the Terraform code, Nginx ingress. We have mentioned two replicas here. So that's why two Nginx ingress control pods are running here. Okay. Just kubectl and get all. It will list all the resources in a set manager namespace. See, these all related to the set manager related pods. Okay, let's clear the screen. And what I have to do, Okay, so now we need to create so let's create the. So in this video I don't want to create this one, any certificate. So let's go to the deployment. So I will set up one application, one demo application. Okay, copy it, sudo vi.yaml. Let's copy this entire code and paste it here. Okay, write and quit. Okay, ingress. This one. Let's create it. This one, hello world ingress.yaml. So this is the ingress controller file. This is the ingress file. So .yaml. Okay, so this is the deployment file, and the service is cluster IP, and this is the second deployment file here, and the service also cluster IP. So once you access the first pod, it will show this title, welcome to Azure Kubernetes services. So when you access the second pod, it will show the AKS ingress demo. So how will you access first pod and second pod? By using this ingress resource. Okay, so we are not providing any SSL certificate here, that's why this is false. We are using the regular expressions here. You can use regex equal to true. Okay, so if you click on that IP address, so if you access this pod by using this IP address, by default it will connect to the AKS hello world 1 pod. At that time you can see this title. If you put slash hello world 1, it will show hello world 1 pod. If you put slash hello world 2, it will show hello world 2 pod. If you put slash static, again it will go to the hello world 1 pod. Okay, let's apply these resources. Okay, kubectl apply -f. So AKS hello world 1.yaml. Apply to .yaml and hello world ingress. Hello world ingress.yaml. Okay, so let's check these resources are created or not. kubectl get pods. So you can see this is running. Okay, AKS hello world 1 pod is running and 2 pod is running successfully. Let's get the ingress resource. kubectl get ingress. Okay, so that ingress is creating the public IP. Let's go to the load balancers here. Load balancers. Just click on this load balancer. Just click on the front end IP configuration. So this is the IP address. You can see it here, 172.214.116.39. So you can access the application by using this public IP. So once go to the browser, and see. So this time you can see this title, welcome to Azure Kubernetes Services. Now you can type this one. Again it will show welcome to Azure Kubernetes Services. So if you click on to, again now it will show AKS Ingress demo. Again you can change the URL to static, and this time it is showing welcome to Azure Kubernetes Services. Here you can